is defined as and summation over k. Summation over k. Now you can calculate between x and p. So this would be del x over del x del p over del p minus 0 into 0, and this would be just 1. Okay. If I had xi pj, then I would have xi pj, then I would have it like that, and I would have a sum over k. In that case, I would obtain sum over k delta I k delta j k. This would be delta ij. Okay, it would be summed over k, right? It would be summed over k. So here for this particular theory, this is the only result. So you have x and p, and this was a bracket would be just 1. And if you calculate between x and x, it would be 0. Between p and p, it would be 0. So what we do in the so-called first quantization, we calculate all the Poisson brackets of the theory among all the phase space variables of the theory, vanishing and non-vanishing ones, and then we promote all the classical variables to quantum mechanical operators following the standard rules of quantum mechanics. And therefore, this would give me x p bar equal to 1 would give me, so Poisson bracket is minus iota by x cross times the commutation relation. This is the famous Dirac quantization rule, which is applicable to mechanics. So this is a classical object, this is a quantum object. Okay, so if I write x and p Poisson bracket, this corresponds to minus iota by x cross times x p. This is the quantum mechanical operator. Commutation relation is a quantum mechanical operator. Okay, so on the one hand side, on the left hand side, you have classical object, on the right hand side you have quantum. And this is the famous Dirac quantization rule. If at some point of time I would be very happy to derive it, but not today. Okay, for when I do the time evolution operator in quantum mechanics, it's such a beautiful description. I was doing it for curiosity, just to discover how these great so-called great brains work. And I was very happy to derive it on two sides and to get it, this equality. How, I mean, it's out of the blue, you cannot have this idea. So there must be something. So, but not today, some other time, okay? Here, now I make, if we have said this, then this would complete the so-called first quantization, okay? And then, what is the second quantization? Actually, the quantization procedure is not complete unless you have achieved the so-called second quantization. So what is then second quantization? And there, this question of Fock space automatically would come in. Okay? N particle state or particle representation would automatically appear. So what we do is we proceed to construct a. So let me just remove all this. Okay. So let me introduce x equals to h cross by 2 omega m times a plus a dagger, and p would then come out to be, I need to define only one, then the other would follow. So p would be iota times h cross m omega by 2 times minus a plus a dagger. Actually, this expression or this representation of expressing x and p as a linear sum of the annihilation and creation operators, which I would derive in a few minutes why they are called annihilation and creation operators. In terms of these, you can also call them Fourier modes. Right now we don't see them in quantum mechanics, but they would be visible as soon as we make a transition to field theory. So our purpose is we want to express x as a linear sum of a and a prime, a and a dagger, and p as a linear sum of a and a dagger. In field theory, what we would do, our x would be replaced by the field phi of x or psi of x or a mu of x. In string theory, this would be replaced by the string coordinate capital X of mu or psi of mu for superstrings psi of mu that we talked about last time. And on this side, you have multiple choices. I can have plane wave expansion, so multiplying them with e to the power minus ikx, e to the power plus ikx. Okay? In field theory. I will write them down too. But we want to catch the logic. And similarly, we will do the same thing in string theory, identically the same thing in string theory. And therefore, if you like, you can invert these equations and you can solve these two equations for a and a dagger. So you will obtain m omega by 2h cross times x plus ip by m omega, and a dagger would be m omega by 2 square root 2h cross and x minus ip divided by m omega. So we originally introduced a and a dagger, some two objects which we would know later what they mean and why should they be called as annihilation and creation operators at all. But we, right from the very first step, we say that they are operators. Operators means they are quantum mechanical operators. Okay? They would obey standard quantum mechanical rules. All right? If you can do that, then there are a few important things that we needed. You can calculate a product of, let us say, a dagger and a, and this would be, you can, I'm skipping the intermediate steps. This would be h by h cross omega minus 1/2, and that would give me h equals to h cross omega times a dagger a plus 1/2, or if I would now define it as n, then I would write it as h cross omega times n plus 1/2. Okay, and then so this is just a very trivial algebra, but what we have done here is we have used the commutation relations of x and p. Okay, for writing this down, you take this. So you take product of a dagger and a is obviously two terms here, x plus ip, some constants, times f minus ip, some constant here, some constant here. So these are, you will get 4 terms, right? And they are now, as I say, they are operators. So x, p, x, x, p, x, p, p. Okay? So to simplify them, you make use of the commutation relation xp equal to IH cross. Okay? The commutation relation of xp, which is xp minus px. Okay? Which is xp minus px p iota h cross. Okay? Very good. Now I would like to define an eigenstate. Okay? So how would I do that? I would like to define and I like this German notation, putting double dots before the equality sign, so I define it. Okay? I define this to be equals to n and n, and then this would immediately I can derive n a dagger n equals to n plus 1 a dagger n and n a n n minus 1 a. These 3 equations are very, very fundamental. I define only one. Okay, then all other things follow. And what is this thing that I am defining? What I say